start? Okay, my name is Brian Krupp, and I'm going to be talking about augmenting mobile security and privacy controls. So just to give you a little background where I came from. Between 2005 and 2012, I worked at KeyBank, first as a distributed systems engineer, mainly working on the security products there. And then I made the jump over into information security, did web pen testing, security code reviews, things of that nature. And then eventually went to enterprise architecture with a focus on the security side as well. So a lot of it's on the system side and the security consulting side. And then I made the jump over to Highland, where I'm currently at, where I'm a software developer and an architect, primarily on the mobile side, and also work with a little bit with security on that aspect with solutions. And then at the end of July, I'll be leaving Highland Software and be joining Ball & Wallace University. So the talk that I'm going to give today is first give a brief current state of mobile, of where it's at from a security and privacy.
That was turned up way too hot. All right, I'm going to come out here with this lavalier mic. Here, let's hook you up with this. Its battery's about dead.
Okay.
When do you do battery? The battery will die now.
Okay. All right. Oh, you got that working now? One bar. I'll keep my eye on it. I'll be quick. Go ahead. All right, so a brief current state of mobile, review existing controls that are there today, talk about available solutions that you have to augment security and privacy solution, and then get into personal research that I've done, and then some final thoughts and conclusions. So current state of mobile, as you know, mobile's fairly pervasive, right? They surpassed PC sales in 2011. 2011 was also a pivotal year where the sales of tablets tripled. The two major platforms that I focused on was Android and iOS, and both of them contain vulnerabilities, not a surprise. But part of the stigma with Android is that it contains more vulnerabilities than iOS, which is not the case. Based on the Semantic Internet Security Threat Report, iOS has 108 documented vulnerabilities, with Android has 18. However, Android contains more malware, and this is mainly attributed to the process that Apple follows, where it's more strict. You can only download applications without jailbreaking the device from one app store, where Android, as long as the application's signed, you could download it from virtually anywhere. And the primary incentive for this malware is financial gain. And the same report showed that 28% track the user, 30% track the user, 28% send information from the device, and 10% will actually reconfigure the device. And this is a new context than that what we're used to with mobile, where compared to your laptop, mobile is equipped with sensors that you've never had before, that can monitor your location, that can read, can record sound, record multimedia. And it's also a trove of personal information. So you have your contacts in there, emergency contact information, phone numbers. These are things that you didn't have on your device before. And the privacy permissions for these platforms are very coarse. Pretty much just generally, can this application access this particular resource or not? You really don't have anything outside of that. And while mobile at the beginning didn't have much security and privacy controls, today they both offer encryption, sandboxing, address space layout randomization, an app review process, even however, there is nothing that is actually authenticating or verifying that intent. So once you grant access to your location, this application can send that data to whomever it wants and monitor as much as it wants. So the application asks for permissions, you grant or deny it. With iOS, it's at runtime, or with Android M, it's at runtime. Previous versions of Android, it's at install time. And the question you have to ask yourself, are you protected based on this permission? So if I say, okay, the weather app can access my location, am I actually protected just to say, okay, well, only the weather app is accessing that location information? And then can we verify this usage? Can we verify this message here? And can we control how that data is being accessed, how it's being used? And the answer is no. So examples of where controls aren't good enough, Facebook will ask for your location at check-in. One of the things I found in my research is that when you close a Facebook application in iOS, once you grant an access to your location, it will report your last location as soon as you close that application. TextNow also asks for location, and then it monitors that location in the background and then sends it to advertisement servers. The weather channel is probably one of the worst cases. It asks for your location for the weather forecast, and this is a legitimate use case. Of course you want to let it use your location because you want to see where the weather is, where you're currently at. And then it sends this data to advertisement servers. Another example with Facebook is that if you were to select a photo to post to Facebook, and this was a sensitive photo that you took, before you post it on the wall, that photo is actually linked to Facebook before you actually post it. So if you didn't mean to select that photo and you selected it accidentally, it already left the device. So there are solutions that exist to augment controls. In the commercial space, there's more solutions for Android than on iOS, mainly because applications on Android have a little bit more permissions. They could do a little bit more than the iOS platform. An example of these are your typical security vendors that you find out there. But the focus is primarily on security, and it's not so much on privacy, although some do offer privacy enhancements. iOS has some security solutions, but really it's mainly notifying you of, hey, here's a new security vulnerability, or some ad hoc antivirus scanning. They pitch it as antivirus scanning, but it's not scanning the platform. It's more like an open-end functionality. However, the advantage, even with commercial shortcomings, is that they're readily available. You could download these and install them on your mobile platform without having to perform a jailbreak or install a custom OS. However, the disadvantage is you don't have that fine-grained control of the data that you have on your device. So there are solutions to augment controls in academia, and they do offer greater privacy protection, but as one of the keynote speakers said, although you have these great ideas coming up from academia, you really don't see them in the commercial space or have widespread adoption. Because part of it, to be honest, is that once they come up with these ideas, they get a paper published, there's not much more incentive to keep going with it. One of those common solutions is Taintroid. Taintroid is built for Android and does dynamic flow taint analysis. So it'll actually monitor data as it leaves the device, and then it lets you know if an application is leaking that data. Another solution is Tissa. taming information, stealing smartphone applications. And they actually allow you to block privacy data from leaving the device and even scrub it. So you can anonymize it. You can send bogus information. For iOS, there is a solution called Protect My Privacy, but this requires the device to be jailbroken. But they actually had a fair amount of adoption, and they crowdsource their policy so that if you were to install an application, you can then say, okay, well, what kind of policy are users using for this type of application, and they get more privacy control that way. And then PIOS, just a static analysis of applications that you have on your device, and will let you know what applications are showing some risky behaviors. So the issues with these existing solutions is that commercials really don't protect against misuse of an application or even a legitimate use by an application. So, for example, the Weather Channel, even though it's monitoring a location, it has a legitimate use for it, but you may not want it to be able to monitor your location in specific regions during specific times of day, or you might want to anonymize that location data. For example, you know, if I'm using a weather application, there's no reason that it needs to know my home address. My zip code should suffice. And then most academic solutions require modification to the OS. However, this is really an unsustainable approach. If you think about how often you get updates for your operating system, this means that whoever builds that modified OS has to incorporate that latest patch or latest update to the OS, and then get it out to the customer. This is also a solution that's not available to everyone. So if I were to take pure 100% Android and then modify that, I can't install that on all devices that run some form of Android. And then also, a user might not be savvy enough to install that. So a different approach is to provide more fine-grained control of users' data. So giving the user the ability to restrict certain elements in a set. For example, I might mark certain contacts that are sensitive to me that I don't want to get leaked off that device. Also, I might mark certain photos on that device that I don't want to get leaked. Restrict or scrub certain attributes. So if I want to connect with somebody on, or if I want LinkedIn to search my address book to find other connections, there's no need for LinkedIn to access the actual street address of my contacts or their phone number. Add spatial and temporal restrictions. So I might not want my location to be gathered during certain times of day so that an application will know where I'm at during those times of days, or there might be sensitive locations where I don't want that data being gathered. And then actually verifying the intent of the application. So the Weather Channel says it's going to monitor our location so it can give us a weather forecast. What it doesn't tell you, that's also sending that data to advertisement servers. There's another application on the iPad that's one of the most popular calculator applications. And it will prompt you saying, we need to use your location for calculation optimization. And of course, in our research, we said yes. And then as soon as it got that location, it sent it off to advertisement servers. So, but your grandma that you just bought the iPad for Christmas to maybe look at photos, if she wants to use a calculator app, she's not going to know the difference. So she's going to accept that because, of course, she wants her calculations to be optimized, and it's going to send that data off. And then also improve the confidentiality of data. So ensuring that when that data is getting sent, that it's getting sent to whom you, only whom you want to be sent to, and then over certain parameters to make sure that it's either encrypted or stored encrypted on disk. So I'm going to talk a little bit about the personal research I did on this, and really the focus was on keeping the OS intact so that we don't require modification of the OS, provide those fine-grained controls I discussed, verify the application's intent. So if the application says, I'm going to talk to just weather.com, ensures that that application only does that. And the focus in this research was mainly on iOS, because really in academia, most of the focus has been on Android and just modifying the OS. So the first iteration of this was called the SPE framework, and this is a security and privacy enhanced framework. And this was built on iOS, as I mentioned, it had less research attention, and it required minimal change to the application. It used a popular approach in Objective-C called method swizzling, where it essentially swapped out the runtime behavior of the application with its own variant. And so this way you can capture all requests to location, all requests to photos, to contacts, and then authenticate that or verify that against the user's policy. And provide the fine-grained security and privacy controls, and then also validate the intent of the application. So if an application said that it intends to only communicate to weather.com, and it starts to send that data to advertisement servers, that communication would fail, because it failed against the intent of the application. And then through this, by capturing all those requests, it can guarantee enforcement of the policy, including link libraries like Google Analytics. So here are some screenshots of the policy application where you can restrict certain attributes of the photo, restrict the location attribute of the photo, data access of the photo. You can set up data persistence policies to require encryption of data. And then you can also restrict photos from getting synced automatically to the cloud. And so these are some of the things that you can do in the SPE framework. Restrict traffic to specific domains, enforce SSL and TLS requirements to make sure that if you have a photo, you want to make sure it's only getting sent over an encrypted channel. And then you can also chain these policies together. So this really gave you fine-grained control. From the findings, we tested several open source applications. And these are some additional screenshots of it here too. Camlingual, Doppio, CycleStreets, Wikipedia, White House, etc. These are open source applications for iOS. We did find several issues where several used insecure network, unencrypted write to disk. Several used Google Analytics, including White House. And then several monitor your location where they really didn't need to monitor your location. So there are limitations with the framework, however. It was a good start because it uncovered a lot of different things. However, it required modification to the application. And developers must have an incentive to do this. You're not going to be able to tell a developer, hey, I want you to adopt this SPE framework and include it in there. That's going to make your life harder. They're just not going to do that. You do have that requirement in the corporate world where you have MDM solutions require their framework to get implemented, but this isn't a consumer solution. And also, the other issue with SPE framework is the customer must build the policy manually. So here you see the JSON for that policy. They would store it on a cloud service and be able to pull that into an application that uses SPE framework. So the next piece that came along in our research was the SPE Cloud Proxy. And this didn't require a modification to the OS, so it stayed with our initial principles. And it also didn't require a modification to the application. And essentially what this did is have your device proxy every request through a cloud service. And we can enforce the fine-grained policies and have a reactive-based policy. So as opposed to the user always creating and specifying these policies, we let the user know, hey, this application is sending this data to this particular domain. What do you want to do about it? Do you want to accept that, or do you want to create a policy around it? The only downside about the SPE Cloud Proxy, or one of the downsides, is there's no guarantee. With the SPE framework, we can guarantee that your policy will be enforced. But the policy is a little bit more fuzzy, so we can't guarantee it. However, the advantage is this device and OS agnostic, and again, it's a reactive-based policy. And as I mentioned, all data inspected. There must be a policy that exists, otherwise the request is blocked. So some more details about this, and I'm going to move pretty fast through this. It uses the KBTA method, which essentially creates abstractions of all the communication. And it uses these abstractions to infer knowledge, such as a privacy leak. It uses a SIFT algorithm for matching photos, and this was ideal because we can then take a photo from that device, scale it down to a very small size, and that SIFT algorithm would be able to detect if a photo is getting leaked because it looks for certain characteristics of that photo regardless of size. So SIFT algorithm fit that really well. And the question is with a proxy, well, how do we intercept SSL and TLS traffic? Well, we created our own trusted CA for the customer, and that customer, as long as they import it on the device, they would then trust the communication through that, so we can intercept any kind of SSL or TLS traffic. And we used the open source low proxy project to build off of, and it requires simple configuration. So the KB, I'm actually kind of short on time, so I'm going to fly through this. But the KBTA method, essentially, when that proxy intercepts traffic, it creates all these different abstractions of what's going on in that request. The KBTA method allows us to take these abstractions and say, okay, based on certain criteria of these abstractions and relationships of them, we can infer knowledge. So what's nice about the KBTA method is you can apply machine learning to this and figure out new attack vectors fairly quickly, or new ways of privacy data being leaked. So there's a long paper on this. If you're interested, you can email it to me, and I can send me your email, and I'll send it to you. But see, here are some screenshots of using this SPE Cloud Proxy. It does require client piece, but here we see that there were some privacy leaks detected. And then so as a user, your post to Facebook will fail if you had a privacy or a sensitive photo that you went to go post. So here we see a privacy leak detected, and then we can take an action on this. So we can allow the domain to receive all photos, receive the specific photo, or so on, and then we could build this policy. And this policy is then built top-down. So we have policies that are generated from a user reacting to these, or policies that are created explicitly by the user. And what was great about this approach, by taking this Cloud Proxy approach, is that we could test virtually any application. And some of the findings we had with these is that we did find several issues with popular applications. We tested the top 15 in every category for iOS, as long as you didn't have to pay for it. 29 of those applications access a location. 8 of those set that location to advertisement servers. And then 3 applications access the contact data inappropriately, and then 1 application misused photos, which is a Facebook application. There are limitations to using a proxy approach, is that you do need that proxy service to be available all the time, right? Because if you're using a mobile device, you always want to be able to reach it. If an application uses OAuth to sign the messages, that's another restriction, such as Yahoo Weather, because you can't modify that request as it comes through the proxy. And then if an application uses app-level encryption, well, you can't really inspect that request. And then finally, certificate pinning is also a limitation, because although you might have a trusted CA on that device, for example, in the Twitter application, if you use certificate pinning, you just can't get around that. So some final thoughts and in conclusion is that commercial solutions, they need to protect your data more. So right now it's very much security focused, but you have so much data on your mobile device, if they don't offer these privacy controls, there's a lot at risk. And then academic solutions are really the ones that require a jailbreak or modified OS. They're just unsustainable solutions. The SPE framework was a good approach to this. However, it needs an incentive. You need all the developers to adopt it, or you need OS producers to incorporate that within their application framework. And the SPE framework solves those shortcomings, but again, it has its limitations. So as more applications adopt OAuth or certificate pinning, the SPE Cloud Proxy won't be able to protect you against those applications. And really, in my thought, the best solution is for mobile OS producers to provide these controls. And while not every user will want to adopt these controls, at least allow the user to turn them on or turn them off based on their need. And we proved that feasibility with the SPE framework. So, any questions? I know I ran through that pretty fast. I had some issues with the microphone, so I wasn't sure how much time I had left. I left my email up there, a website that I'll be switching over shortly, but if you have any questions, in the future, want to shoot me an email, I also have some of my work up there. Feel free to email me. Thank you.